Okay, the first example is, oh, by the way, this question says that express the given limit as an integer. It doesn't say that evaluate it. Evaluation is another thing that we will do later when we learn more about the limits, when we learn about the definite integral of fundamental theorem of calculus. But for now, we are just trying to express it as an integral. Remember that limit of right-hand point or left-hand point of a continuous function as n goes to infinity will give you that integral a to b f of x dx. Now, we have to look for pattern that appears here. What are these patterns? Well, delta x is a number b minus x, the length of the total interval, divided by n. How about f of xi minus 1? So f of xi minus 1 is a plus I minus 1 times delta x. So the pattern is this, that first of all, you have to find a multiple in the summand which has a number over n. And the second thing is that you have to look for something like this, a plus I minus 1 times something. And that delta x must be exactly what you took as delta x on the outside as a pattern. So here, right away, I notice there's a 1 over n here. And 1 over n, or any number over n, is a pattern for delta x. So I'll take that inside the sum. One over. And then, okay, so that could be my delta x. If delta x is that, what kind of information that will give me? So if 1 over n is delta x, then that means that b minus a over n is equal to 1 over n. And since this is for every n, that means that b minus a is going to be 1. Fixing delta x doesn't tell me what is a and b, just tells me what is the difference of a. Now that I have that, so let me just take this one and put it on the right hand side. That's something that we just could figure out. Now I can go ahead and try to see what is happening here. So I can rewrite this whole thing as 2 times. You see, this I minus 1, first of all, this is exactly the same I minus 1 there. And then times delta x, here 1 over n, I will write it separately. Well, how about the a? There is no a there, so I can take a to be 0. So this is my a, this is I minus 1, and this is delta x. I can do that right away. That implies that I fixed a. A is equal to 0. That means that, well, the b minus a was supposed to be 1. That means b minus 0 is equal to 1. That means b is 1. We fix the boundaries of the limit. How about the function itself? Okay, so if this is the case, remember a plus I minus, oh, I put this bracket in a little bit bad place. This is better one. Okay. I am trying to point to different things each time I go over, so that's why you see tons of written things. Okay, so if this is the case, this is delta x, and this whole thing is going to be I minus 1. So that is another thing. F of xi minus 1, that's the other multiple of the summand, is going to be 1 minus 2 xi minus 1, sorry. Well, that tells me what is xi, well, f of x. Wherever you see f of xi minus 1, take it out and put x. F of x is 1 minus 2x. I found a function I found the A and B, and right away I can write that this sum or that limit is equal to integral from A0 to B1. F of x is 1 minus 2x dx. I express that guy, that limit of sum as one limit, one integral. Okay. What will happen for the second one? Okay, so I will start again seeing the pattern. Pattern is what? So limit of f of a plus I delta x, which is xi, times delta x. You may say, why did you choose the left hand point up there, but now right hand point down here? Here, the point was that I had I minus 1 multiplied to something. That means that you're dealing with left hand point. Here, I have one thing which is right I times something. That means that most probably we are going to deal with right hand point. Okay, and log of a number added. So let me just write this part here. Log of a number added to I times something. Isn't that the pattern that we are looking for? A plus I delta x. Okay, yes. So that most probably is my xi, which is I plus 1 plus I delta x. Assuming that delta x is 3 over n. I am not done. I'm just trying to find these different patterns. If that's the case, I have to find this delta x, which is 3 over n. That's what I assume now. I have to find it outside, multiply to this whole sum. I see there are some good multiples here. Look at this part here. I can write that part as 3 times I over n squared times a 1 over n. Yeah. But I need 3 over n, so maybe I should do something else here. What should I do? Yes, okay, I can multiply this by 3, divide the whole thing by 3. So this way, let me rewrite this, what I have assumed here. So this is limit of 3I over n squared times 3 over n. Oh, there's a sum here. Okay. Let me log of 1 plus 3I over n. Then there's 3 over n out there. And I'm trying just to show you that what is the best thing here to choose. Right away, I noticed that that plus 1 I am missing here. I don't have that plus 1. Then I can change my mind because who's forcing? I can say that, well, this is only log of 1 plus 3 times xi. Oh, I missed 1 over 3 there. 3 times xi. That is another form that you can go ahead, but I will stick to what I have chosen already, and I will try to do it without going into that other direction. Okay, so here now I have my delta x here, 3 over x. Right away from that, there I can conclude that b minus a is equal to 3. And based on what I have chosen here, basically I have set up a equal to 1. And from these two, I see that b must be equal to 4. I found that part. Now I have to go ahead. So this is my delta x, and I have to make sure that everything else that is there, I have to make sure I can generate that a plus f of a plus I delta x. So in this case, I am missing that one that appears here uh, as we chose already. So what I do is that I add one to that piece. And just to make sure that I haven't changed anything in a bad way, I subtract the same I. Then square here log of 1 plus 3I over n times 3 over. Now that I have this 1 plus, I know that this piece is xi, this piece is xi, this is delta x. Basically, what I have there is mine f1 negative 1 plus xi log of xi. And this is f of xi. Well, from there, you just found what is f of x. Oh, there's a square there. That's what you found as, oh, this should be outside. You just replace xi's by x, and you have found the function. And we can go ahead and write this now as an integral. There's 1 over 3 there. I will put it outside. Then integral. A is 1, B is 4, so 1 to 4. F of x is this guy here, negative 1 plus x squared log of x. Well, we expressed our sum of limit as an integral. Can we evaluate that? That's another story, for which we need maybe to generate to develop more tools. But what question was asking was express this limit as an integral.